rate constant for first order reactions. So let's derive the rate equation for the first order reaction. First order reaction means the reactions whose rate is determined by the change in only one concentration terms. The one concentration terms are known as the first order reactions. So that means the rate of the reaction, it is depending upon only one reactant's concentration. If you change the concentration of the one reactant concentration, then automatically it will affects on the rate of the reaction. So the type of reactions are known as first order reactions. Let's derive the rate equation for the first order reactions. So for this purpose, so let's check a equation. So like this, A gives rise to products. So this is a reaction. So in this reaction, rate is depending upon the concentration of the EA. So initially, before starting the reaction, the concentration of the reactants must be A. Let it be a the concentration of the reactants initially. That means at a time 0. At time 0, there is a no formation of products. So that is why the concentration of the products, it is equal to 0 at a time 0. Of some time, that means at a time t, some of the reactants converts as a products. So here, after some time, the concentration of the products, here it is, let it be X. Here it is the X. And what happened to the concentration of the A after formation of products with concentration X? So that is equal to A minus X. That is equal to A minus X. So after time T, what is the concentration of the A? So that is A minus X. What is the concentration of the products? So that is X. Yes, we know that the rate of the reaction, it is directly proportional to the concentration of the reactants. Because it is a first order reaction, so that means the rate of the reaction, it is directly proportional to the concentration of the reactants. So here, what is the concentration of the reactants after some time? So that is A minus X. We know that the rate, it is directly proportional to the reactant. So that is why we are writing the rate. That means dx by dt, it is directly proportional to the concentration of the reactant. So what is that? A minus X. See this one, the power 1. 1 means, that means the rate of the reaction, it is depending upon the one reactant's concentration. So that is why we are writing the A minus X power 1. Isn't it? Yes. So here, A power, that means A power 1 or N power 1, that is also is equal to A. So that is equal to N. So here also, something power 1 means something. Which one is present in the base? So that would be written. So here A minus X power 1 means A minus X. So after removing the proportionality, we can keep A1 constant. So that is K1. Here it is a constant. After removing the, we can get the dx by dt is equal to K1 into A minus X. So here, what is the K1? Even it is known as the first order rate constant. Here it is known as first order rate constant. See this. So take the a minus x this side and dt this side. Then you can get this type of reaction. So after rearrangement, so what you can get? So that is dx by a minus x is equal to k1 into dt. Then do the integration, the above reaction with its limits. So on integration, then you can get the integration dx by a minus x is equal to k1 into integration dt. Yes, you know that since from the mathematical formulas, integration formulas, so integration 1 by x dx, so that is equal to log x. And also since integration x, that is integration dx is equal to x. So same way integration dt means is equal to t. So here, how can you write the? So this one, if you observe this one, integration dx by 1 minus f, a minus x. So here, what happened? Integration 1 by a minus x dx. See this one. So this is just like 1 by x. So since it's a x, then what is that integration 1 by x dx? Yes, according to formula, that is equal to log x. So we are writing the log x in the place of x. You can write it as a minus x. Only x is present, then it is no problem. But in the place of x, so something another function is there. So that is a minus x is there. If it is like this, you can do the derivative after the integration. So that means log 1 by x here in the place of x, what is that? A minus x is there. Then into derivative, do the derivative for whole the g minus x derivative, do the derivative. So for this purpose, we are writing the, so here a means a, it is a constant. So derivation of constant, so that is equal to 0. Derivation of x dx by dx by the dx derivation, do the derivation. Then what happened? So here derivation, we are doing the derivation with respect to x. So that is d by dx, d by dx of a minus x. Since a is equal to a, it is a constant. If you derivative to the a constant, so that is equal to 0 based on the formula. So that is equal to 0. So here what happened? Dx x after derivating the x with respect to x. So that is dx by dx. So that is equal to 1. Since here it is a minus is present, so that is why here it is a minus 1. So after doing the formula, then you can get this type of that one log a minus x. Since 1 by x dx is equal to log x. Whether since here it is a no single x is present, so along with the x, a minus x is there. So that is why you have to do the derivation to this part a minus x. So after doing the derivation, you can get the answer minus 1 into minus 1. So finally, you can get the minus log a minus x. See this way, right? Minus log a minus x. So therefore, integration dx by a minus x, so that is equal to minus log a minus x is equal to k1 because it is a constant. So that is why we are writing outside the derivation. So integration dt is equal to t. So k into t plus some error, so that is integration constant. Here we can call as a integration constant or error of the integration. We have to find out the error in this equation. So that is we have to find out the c value. See this. So after integration above equation, then you can get the finally this equation. So it is minus log a minus x is equal to kt plus c. Let it be equation number 1. So here what happened? C means integration constant. So here we have to find out the integration constant. So how can you find out the integration constant? See here. So when the time is equal to 0, then x is equal to 0. Time is equal to 0 means initial. X means x. What is the x? What is the x? It is the concentration of the products. See this. X means concentration of the products. Initially, there is a no formation of products. So that is why x is equal to 0. T is equal to 0 means before starting the reaction. T is equal to 0. Then x is equal to what happened? 0. So substitute these two values in this equation. See this one. Then you can get the minus log a minus x plus. In the place of x, you have to substitute 0. In the place of t, you can substitute the 0. Then you can get this type of equation. Minus log a minus 0 is equal to k into 0 plus c. A minus 0 means 0. A minus 0 means a minus log a is equal to k into 0, 0 plus c. Then finally you can get the c value. So that is c is equal to log minus log a. Yes, after find out in the c value, substitute this c value in this equation. Let me substitute the second equation in the first equation. After substituting the value, then you can get this type of equation. So that is minus log a minus x is equal to kt plus c. Is that this? In the place of c, you can substitute the minus log a. So that is why here it is the minus log a. So take minus log a this side. Then what happened? Log a minus log a minus x is equal to k into t. Take the minus log a this side. Then what happened? Here it is a minus log a this side. After going the left side, then it become a plus log a. So log a minus log a minus x. So here, see this one. Observe this equation. So it is since formula based on the formula. So that is log a minus log b. So that is equal to log a by b, or log m minus log n. So that is equal to log m by n. So by using this logarithm formula, you can write it as log a by a minus x. See this one. This is just look like this one. Log a minus log b. You can write it as log a by b. So that is why we are writing the log a by a minus x is equal to k into t. So write down the equation for the rate constant. So that is by keep the k1 and take the t this side. Then what happened? K1 is equal to 1 by t into log a by a minus x. See this one. Here it is a logarithm. So that is in the exponential logarithm. So here it is. To convert the base 10 logarithm, you have to multiply with the 2.303. So this logarithms. So it is the exponential logarithm. So this is, see this one, this log is, it is a base 10 logarithm. So when you want to convert the exponential logarithm to the base 10 logarithm, just you have to multiply with the 2.303. So that is why the log is equal to what happened? 2.303 log. So write down this value in this place, then you can get this type of equation finally. So that is K1 is equal to 2.303 by T log A by A minus X. So what happened, that is K1 is equal to 2.303 by T log A by A minus X. So this equation, it is known as first order rate equation. Rate equation for the first order. What is the rate equation for the first order? So that is K1 is equal to 2.303 by T log A by A minus X. And next one, find out the units. So what are the units for the first order equation? So by using this equation series, by using this equation, you can easily find out the units for the rate constants. So that is here, since what is the rate equation? So that is K is equal to 2.303 by T log A by A minus X. 2.303, it is the constant value. A means the concentration. A means concentration. A means initial concentration. A minus X means the whole thing. It is also a concentration value. A means concentration. Concentration by concentration, it is also cancelled. 2.303 means it is a constant value. So remaining what is there? T is there. That means what? K1 is equal to 1 by T. T means, so that is time. What are the units for the time? Second. Yes, we know that the second. Seconds are the units for the time. So take the 5, then you can get the second inverse. So what are the units for the first order rate constant? So that is second inverse. Second inverse for first order rate constant. K is equal to second inverse. These are the units. And next one, uplife. And we have to find out the uplife equation for the first order first order reaction. Uplife means the time taken to the time taken to complete the 50% of the reaction. So that is known as uplife. To find out the uplife equation, by using this equation, first order rate equation, we can easily find out the uplife time. So uplife means time means off period. So that is why T becomes T off. What happened? What about the concentration? Concentration means here also 50% reaction must be converted as the products. Reactants converted as the products. So that is why, what is the concentration of the X? 50% of initial A. 50% of that A by 2. So substitute the T is equal to T of and X is equal to A by 2 values in this equation. Then you can get the K is equal to 2.303 by T of to log A by A minus X. X in the place of X, we have to substitute the A by 2. So this one, what happens here? A by 2. Then A by LCM, do the LCM 2A by minus A by 2. So A by 2A minus A by 2. Yes. So after simplification of this, you can get the K is equal to 2.303 by T of log A by 2. Here A cancel. So remaining what is that? 1 by 2. Take it upside. Then you can get the K is equal to 2.303 by 2 of log 2. So substitute the log 2 value. So that is, since log 2 is equal to 0.3010, substitute that value in this equation. Then you can get the K1 is equal to 2.3010 G of into 0.3010. Sorry, here it is the condition. So since it is a 2.303. So it is 2.303. K is equal to 2.303 by T of into 0.3010. After substituting the like true value in this equation, then you can get this equation. So after multiplication of this 2.303 into 0.3010, then the value is equal to 0.693 by T of. See here, K is equal to 0.693 by T of. So write down the equation for the T of, then you can get this type of equation. So that is T of is equal to 0.693 by K1. So by observing this equation, so one should be know that so the first order of reaction, the half-life, since the half-life it is a independent half-life, it is a independent on the initial concentration of the reactants. Since in this equation there is a no concentration terms, so that is a T of means half-life it is a independent on the initial concentration of the reactants. So this is about the half-life on the first order reaction. The next one is graph. So by plotting the graph, then you can easily find out the what is the slope. That means rate constant. See here, there are two ways. The first one is when you plot a graph between the log A by A minus X versus T. See this one. If you plot a graph between the log A by A minus X versus T, that must be the line must be gone from the origin line. See, from the origin point. So if you plot a graph between the log A by A minus X versus T, then you can get this type of graph. See this one. So on y-axis, you can check the log A by A minus X values. On x-axis, you can check the time value after plotting the graph. Then you can get this type of line. So this is the slope. So that is the slope. The slope must be is equal to K by 2.303. It must be K by 2.303. So this is the one way to draw a graph. Another way, for example, the second way, if you plot a graph between the log A minus X versus T, see this one, log A minus X versus T, then you can get this type of graph. See this one. Take the log A minus X values on the y-axis and time on the x-axis. If you plot a graph, then you can get this type of graph. Here it is the slope. See this one. Here is a slope. So that is must be negative. So that is why you can get this type of line because it is a negative. So what is that? Minus K by 2.39. See, that is the slope. So these are the two ways to draw the graphs. So first one is, what is that? Log A by A minus X. So since what is the equation? So here it is the equation. So that is see this one. See this one. See this. So this is the equation. So that is a log. Here it is a log. What is the equation? So that is log A by A minus X is equal to KT. Since it is the log, this log. So that means if you write down the log A by A minus X by 2.303. So this equation, so that is equal to y is equal to mx. So mathematical equation, so that is y is equal to mx. So what is the graph? Let's look like So this equation, so that is mathematical y is equal to mx. So it is just look like this one. So this is also very similar to the y is equal to mx. So that is why you can get this type of equations. So coming to this one is equal to log a minus x is equal to minus k 2.303 t. See this one. So here the second one. What is the equation? The equation is log a minus x is equal to minus k by 2.303 t. Since it is a y is equal to minus mx. What is the graph? It is just look like this. So by using this equation, you can get this type of graph. Whether you can draw the graph by using this equation, then you can get this type of graph. So this is about the graph. So there are some examples. So let's see the examples for the second order reactions. Sorry, first order reaction. The first example for this thermal dissociation of nitrous oxide. Thermal dissociation of nitrous oxide, nitrogen pentoxide, hydrogen peroxide, and sulfuryl chlorides are the best example for the first order reactions. So what are the reactions? The dissociation of the nitrous oxide. So there is seen from the first reaction, N2O nitrous oxide that is dissociated into nitrogen oxide. We observe the second equation, so there is a nitrogen pentoxide dissociated into 2NO2 plus half oxygen, half hydrogen, half oxygen. And next one, so there is nitrogen pentoxide. So here it is also the decomposition. So there is nitrogen dioxide plus oxygen. We have the two molecules. So the two molecule dissociation into nitrogen dioxide plus oxygen. And next one, so there is hydrogen peroxide. The dissociation of the hydrogen peroxide, so that is equal to water plus oxygen. And the next one, so that is sulfuryl chloride. And the sulfur chloride associated to this sulfur dioxide and chlorine. So these are the best example for the first order reactions. That means in these equation, in these reactions, the rate of the reactions must be depending upon the concentration of this reactants. So that is why it is known as the first order reaction. The second one, so that is a molecular rearrangement of the cyclopropane. The molecular rearrangement of the cyclopropane into the propylene, and also the conversion of N-chloroacetal. Second one, what is that? The N-chloroacetylene. Acetylite. So acetonolite to parachloroacetonolite. See this one, the first reaction. So here it is a cyclopropane. And this is a cyclic property. After the rearrangement, then it converts as a propane. See this one. So it is a propane. Next one is the conversion. So N-chloroacetonolite to parachlor. Here it is parachloroacetonolite. So these reactions are best example for the first order reactions. Here also rate of the reaction, it is depending on these two reactants. So that is cyclopropane and N-chloroacetonolite. And the third one, See this one? What is the best example for this one? So here it is the hydrolysis of methyl ester in acetic media. Hydrolysis of methyl ester. That means ester. Here it is methyl ester and hydrolysis in the presence of acetic media. So it converts the, see this one. What is this? So this is the acetic acid. So it is alcohol. So in this reaction, the rate of the reaction, it is depends only on the ester. This one. Only ester, but not on the amount of the water taken. So this type of reactions is also sometimes called as a pseudophosphate reactions. Pseudophosphate reactions. See here, if you observe this reaction, so there is hydrolysis of methyl ester. So there are two reactants are there. What is that? So ester, so that is methyl ester and also water. So when you observe this reaction, the rate of the reaction, it is only depends upon the concentration of the this ester only. It will not depend upon the amount of water which is taken in this reaction. So that is why this reaction, which is known as the first order reaction. And the next one, so that is hydrolysis of sucrose. So hydrolysis of sucrose in acidic media, and also the hydrolysis of benzene diazonium chloride. These two reactions are the pseudophosphate reactions. See this one. Sucrose and hydrolysis, it will give the carbohydrates, that is glucose and fructose. And the next one is that is benzene diazonium chloride and hydrolysis. It will give the phenol and nitrogen as well as HCl. So when you observe these two reactions, so how many reactants are there? Two reactants are there. In the first reaction, that is sucrose and water. Second one is benzene diazonium and water. So the rate of the reaction, the rate of these two reactions is only depends upon the concentration of the sucrose and the concentration of the benzene diazonium chloride. It's only depending upon the in this reaction, the rate is depends upon the this sucrose only, the concentration of the sucrose, but not the water. Here also the same reaction, the rate of the reaction, it is depends upon the benzene diazonium chloride concentration, but not the water. So that is why it is known as the first order reactions, and also these are known as the pseudo first order reactions. And next one, so that is decomposition of the oxalic acids into carbon monoxide and water. The decomposition of oxalic acid into carbon monoxide and water is, so this is oxalic acids. Decomposition, it will give the carbon dioxide, carbon monoxide and water. So in this reaction, it is also the rate of the reaction is depends upon only the concentration of the oxalic acid. So these are the best example for the first order reactions. So what is the rate equation for the first order? So that is equal to log a minus x. So this is a rate equation, that is k is equal to 2.03 by t log a by a minus x. And what are the units for the rate equation? So that is k is equal to second inverse. K is equal to second inverse, and half-life. So that is half-life. So that is 0.693 by k1. So that means half-life. It is an independent parameter. That means it will not depend upon the initial concentrations. So these are the two graphs, the possible graphs, depending upon the what question that you are taking to draw a graph. So these are the two graphs are possible for this first order. So these are the some examples for the first order reactions. So let's see examples of problems. See here, if you observe this problem. So first one is the following data is obtained the decomposition of an aqueous solutions of hydrogen peroxide. So these are the values of the decomposition of the hydrogen peroxides. So initially, here what is that? The time here is at here it is the time at 0. What is the value of km mole that required? That is 42 ml at time 10 minutes, 27, 20 minutes, 17.9, 30 minutes, 11.2. That means volume of km mole required to react with the definite volume of the hydrogen peroxide solutions C. At time 0, what is the concentration km mole? So that is 42, 10, 27, 20, 17.9, and 30, 11.2. Yes, we know that. See this one here are the from the given the data that at 0 time the titer value it is proportional to the what is initial concentration of the hydrogen peroxide. So that is A. See this one A the titan value at any at a time T correspond to the undecomposition hydrogen peroxide. So that is A minus X. The initial what is that? A means initial concentration. So initial concentration that is equal to what is it at time 0? What is the value of required to the titrate? Titrate the titrate value. So that is 47. See this one. It is a 47. A must be 47. See this one. Then A minus X means with a different time travels. With a different time travels. Then substitute that values in the first order reaction. So what is the rate equation for the first order? Yes, we know that K is equal to 2.39 by G log A minus A by A minus X. Okay. What is A? A means 47. A minus X means at different time travels. Yes. If you observe the data, this is the time. At time 0, this is the initial. Okay. And this is at time 10 minutes. What is the concentration? 27. That means A minus X. So this is the A minus X and this is the T. Okay. Then substitute that. A means 42. A means 42. See. Substitute the values. A by A minus X. See this one. Second, what is that? 10 minutes. After 10 minutes, what is that? 42 by 27. The value that must be is equal to 4.42 into 10 to the power of minus 2 minutes. And at time 20 means 2.3 by 20 log 42 by 20 minutes. What is that? 17.9. The value then must be equal to 4.27 and 30 minutes. What is that? 11.2. And that is equal to 4.41 into 10 to the power minus. Yes. Since K comes out, it becomes a constant in 3 cases. So the reaction is the first order. So the average rate must be do the average of these 3 values. Then you will get this type of value. So that is K is equal to 4.37 into 10 to the power minus minute inverse. So it's a problem for the first order reactions. So in the same way, this is a problem. So here also time 0 at time 0 and different type of concentrations. So T that is 0. So this is A and these are the A minus X values. So substitute these A and A minus X values with different time travel. See in the first order rate equation, then you can get the this type of value. See this one. Then do the average of these two values, so then you can get the K value. So this is about the first order reaction.